Imagine logging into your development server one morning only to discover that your Ethereum wallets have been drained and that someone else has complete control of your entire system. Sounds like a nightmare? Well, in October 2024, cybersecurity researchers uncovered a sophisticated attack that turned trusted development tools into a silent backdoor. If you're a developer working with Ethereum or just someone interested in cybersecurity, you need to watch this video until the end. We're going to break down one of the most sophisticated supply chain attacks of 2024. Let's start with what makes this attack particularly devious. The attackers didn't go after obscure packages that nobody uses. Instead, they targeted one of the most popular and trusted tools in the Ethereum development ecosystem, the Ethers package. With over 1.3 million weekly downloads, Ethers is the backbone of countless Ethereum applications. But here's where it gets interesting. The attackers created several convincing copycat packages with names like ethers-mew, Ethers Web 3, and Ethers Audit. At first glance, these packages looked completely legitimate. They had professional documentation, proper versioning, and even maintained the same functionality as the real Ethers package. This wasn't some amateur operation. This was a carefully orchestrated attack designed to slip past even experienced developers. But what makes this attack truly fascinating is its patience. Unlike typical malware that triggers as soon as you install it, these malicious packages would sit quietly in your codebase, waiting for the perfect moment to strike. They would only activate when a developer actually used the package to create a new Ethereum wallet. This patience made the malware incredibly difficult to detect during standard security scans. The attack itself was a masterclass in deception. When a developer creates a new wallet using one of these fake packages, the code springs into action through a series of carefully disguised functions. The names of these functions were deliberately chosen to sound legitimate: check address, check server, and supersign key. Anyone reviewing the code might assume these were standard security checks rather than malicious operations. Let's break down exactly how the attack worked. When you create a new wallet, the malicious code would first trigger a function called check address. Sounds innocent enough, right? But this function was actually the first domino in a chain of deception. It would call another function named check server, which, despite its name, wasn't checking anything. It was secretly sending your Ethereum private key to a domain called ethersign.com. Now the attackers went to extraordinary lengths to make this domain look legitimate. They registered it just days before the attack, on October 15, 2024, and hosted it on Hetzner Online, a reputable hosting provider. Everything about the operation was designed to appear as normal as possible. But here's where the attack gets even more sinister. While you might think stealing private keys would be enough, these attackers wanted more. They included another function called supersign key that would stealthily modify your system's SSH configuration. In simple terms, they were creating a backdoor that would give them complete access to your entire machine. This backdoor was particularly clever. The malicious code would add the attacker's SSH public key to the root user's authorized keys file. For those not familiar with Linux systems, this is essentially like giving someone a master key to your house. They can come and go as they please, accessing anything they want on your system. The technical sophistication of this attack was remarkable. The malicious code was buried under multiple layers of legitimate-looking functions, spread across different files. This modular approach wasn't just about hiding the malware. It was exploiting the very nature of how modern development works, where code is split across multiple files and modules for better organization. What's particularly concerning is how successful this campaign was. Even though these packages were only available for a short time, they managed to accumulate hundreds of downloads. The most popular package, ethers-mew, was downloaded 781 times, while ethers-test received 336 downloads. Each of these downloads represents a potential compromise, a developer or organization that might still be unaware their systems have been infiltrated. This attack wasn't an isolated incident. In August 2023, security researchers at Phylum uncovered a similar but less sophisticated attack targeting the Ethereum cryptography package. Let's examine this historical precedent that likely inspired our current attackers. The 2023 attack focused on typo squatting, creating a package called Ethereum cryptography. Notice the subtle extra Y. The attacker, operating under the username Jackshan crafted an almost perfect clone of the legitimate Ethereum cryptography package, which normally sees over 1.2 million weekly downloads. What made this earlier attack particularly clever was its manipulation of dependencies. Instead of directly inserting malicious code into the main package, the attacker created a Trojanized version of the @noble/curves package, a critical dependency for Ethereum's cryptographic operations. Here's how they did it. JavaScript showed original legitimate dependency, a dependencies. Neuron with noble curves, what do you know, neuron malicious version dependencies, and an Jackshan curves. 1.1.0. Notice the subtle change. It began on August 3, 2023, with the initial release of a Jackshan/curves v.110, marking the attacker's first foray into the NPM ecosystem. Over the next 24 hours, we observed a rapid iteration of multiple versions, each building upon the last, as the attacker refined their approach and tested various techniques. The campaign culminated in the release of version 1.19, which incorporated more sophisticated obfuscation techniques to avoid detection. Before security researchers identified and removed the package, it had already accumulated over 500 downloads, each representing a potentially compromised development environment. When we compare this earlier attack to our current 2024 campaign, the evolution of these threats becomes strikingly clear. The 2023 attack, while dangerous, was relatively straightforward in its approach. It utilized a single-stage payload that directly exfiltrated private keys without much complexity. Its obfuscation techniques were basic, primarily relying on code minification and simple variable naming schemes to avoid detection. The attack didn't attempt to compromise the underlying system, focusing solely on cryptocurrency theft. Perhaps most notably, it used a rather obvious China-based exfiltration server at wallet.cba123.cn, making it easier for security researchers to track and block. In contrast, the 2024 attack represents a significant leap in sophistication. The attackers implemented a multi-stage payload system that carefully evaluates the target environment before deploying its full arsenal. Their exfiltration methods are remarkably advanced, using multiple fallback servers and legitimate-looking API endpoints to avoid detection. The obfuscation techniques have evolved to include anti-debugging measures, environment checks, and clever code splitting across multiple modules. Beyond just stealing cryptocurrency, this attack establishes persistent access through SSH backdoors, demonstrating a more comprehensive approach to system compromise. Perhaps most impressively, the attackers created professional-looking infrastructure, including legitimate-seeming domains and proper SSL certificates, making it much harder to distinguish their malicious operations from legitimate services. This evolution from a relatively simple cryptocurrency theft mechanism to a sophisticated multi-purpose attack framework illustrates the rapidly advancing nature of supply chain threats. It serves as a sobering reminder that attackers are constantly learning, adapting, and improving their techniques. What's particularly concerning is how each successful attack seems to provide a blueprint for more sophisticated future attacks, creating an ongoing cycle of escalating threats to the NPM ecosystem. The attackers were clever enough to maintain nearly identical documentation to the original package. They even included professional-looking profile pictures on their NPM accounts. One attacker used a photo of Tim Waring, a well-known Yorkshire property expert, to add credibility to their fake account. This brings us to the importance of package verification. Before installing any package, especially one handling sensitive operations like cryptocurrency transactions, verify its authenticity. Check the number of weekly downloads. Legitimate packages usually have consistent download patterns. Look at the package's GitHub repository, examine its contributors, and read through recent issues and pull requests. The attack also highlights a critical principle in security. Never trust, always verify. The malicious packages maintained all the same functionality as the legitimate Ethers package. Everything worked exactly as expected. except for the hidden malicious code. This is why automated testing alone isn't enough to catch these types of attacks. Let's talk about some specific red flags that could have identified these malicious packages. First, they were all published by new accounts with minimal history. Second, they had significantly fewer downloads compared to the legitimate package. And third, they included unnecessary dependencies that weren't present in the original package. However, perhaps the most important lesson from this attack is the danger of implicit trust in the NPM ecosystem. Just because a package is available on NPM doesn't mean it's safe. The attackers in this case were able to publish multiple malicious packages and accumulate hundreds of downloads before being discovered. This brings us to a broader discussion about supply chain security. The NPM ecosystem, like many other package managers, operates on a model of trust. Developers trust that the packages they're installing are safe and that trust can be exploited. This is why organizations need to implement proper supply chain security measures. It's also worth noting that this attack specifically targeted cryptocurrency operations. If you're developing applications that handle cryptocurrency or other sensitive financial operations, you need additional layers of security. This might include code review requirements for any packages handling private keys, or even implementing air-gap systems for critical operations. The future implications of this attack are concerning. As cryptocurrency becomes more mainstream and more developers build blockchain applications, we can expect to see more sophisticated attacks targeting the development ecosystem. The attackers are getting better at hiding their malicious code and making their packages look legitimate. Remember the packages involved in this attack: ethers-mew, ethers-web3, ethers-6, ethers-eth, ethers-aaa, ethers-audit, and ethers-test have been removed from the NPM registry. But there's nothing stopping attackers from publishing new malicious packages with different names. The threat remains active and evolving. Have you encountered suspicious packages in your development work? Share your experiences in the comments below, and don't forget to subscribe to the channel.